and today I'm gonna discuss part 4, that is related to VRF system designing and selection using VRF selection tool software. So there I have the main screen of the VRF system selection tool software, and here in the Excel sheet, as you can see that we are going to use these loads to design our VRF system. This is the cooling load and this is the heating load for all the spaces mentioned over here. So total cooling load is 51.4 kilowatt and total heating load is 52 kilowatt, and these are the outdoor design conditions which we are going to use when we design our system. So let's move back to our VRF selection tool software. But before starting this VRF selection tool software, let me show you one thing over here. This is the flow chart of the selection tool software which you have to understand over here. Basically we start or create the project first, and then we select the method. Basically two types of methods are available here in this VRF selection tool software. One is a wizard type selection, that is detailed design method, and the other one is drag and drop drawing method. So in wizard type selection, we select and set indoor. After adding this outdoor temperature information, we will select or set indoor units in the wizard type selection. So after selecting our indoor units, we will move to the next tab, that is related to selection of outdoor units. So when you finish the selection of outdoor unit, you will link them, indoor and outdoor unit, you have to link them, and then you have to create the piping will be created automatically depending on your indoor and outdoor unit capacity. But in drag and drop drawing method, you will create the refrigerant piping first, and then you will select or set your indoor units, and then you will move to the next tab and select your outdoor units. So in the end, you will select the central control device, and then you will create the output project of your data. So only difference between these two methods is here you will select first indoor unit, outdoor unit, then link them, and then piping diagram will be automatically created. But in drag and drop drawing, first piping diagram, refrigerant piping diagram you have to create, then set your indoor and outdoor units. So today I'm going to discuss this drag and drop drawing method to create our system. Later we will discuss about this wizard type selection. So let's move back to our selection tool software over here. So as you can see that this is the main screen of our VRF selection tool software, and the different options available over here. First you have to create the project. So in order to create the project, you can either click here, that is create project, or you can go to edit, this option here, that is create project. So we'll create project first, and this screen will appear, and then you have to give the information over here. So let's say I'm going the project number as 111, and project name, whatever the project name you have to specify here, and customer name maybe like CC, and make sure that all the entries with the star, it's necessary to fill up. Other entries, it's up to you whether you want to fill or not, it's up to you, but when you start your project you have to fill all of them. So and then you can also give the address, you can specify the installer, whoever the installer, you can specify the name or company name, you can specify the installation date, let's say it's 31st or 28 February, and commissioning date, let's say it's 28 March, whatever the date you can select over here. So after selecting everything, you just have to save here. And if you want to edit your project data again, so you just select your project over here and then go over here, this is the edit project, or you can go over here edit and then edit project. So you can edit the entries once again once this window is open. So once this step is finished, creating your project or editing is finished, you can either double click this one, just select the project and double click to move to the next step, or you can select from here also, this is the next step, or go edit and go to the next step. So I'm going to the next step by double clicking. Once you double click this one, it will ask you about the method, which method you want to use. You know that the method which I told you, one is a wizard type selection, other is a drag and drop drawing method. First one is a wizard type selection, second is drag and drop. Today I'm going to discuss drag and drop drawing. So I'm going to select this one, and then I will select this next button, or you can go to edit and next button. So I'm going to select this next step. Once you select the next step, then this new window will appear. Here you have to give the outdoor information, outdoor temperature information over here. Remember that I talked to you about the location in which I am working right now. The outdoor design temperature conditions are this one for cooling and for heating. So move back to our software and I will click outdoor temperature information. So in our location, outdoor cooling dry bulb temperature is 107. So I'm gonna select 107 cooling dry bulb temperature, and heating wet bulb temperature is 37.7. So 37.7. So once you select these temperatures, cooling dry bulb and heating wet bulb, you can save it and then exit here. So after selecting your outdoor temperatures, you have to go to here, that's new. New means you will create a new refrigerant piping diagram over here, or you can go here also in the edit tab and you can select new. So I'm going to select new to create a new refrigerant piping diagram. So I will select here new. Once you select new, this window will appear. As you can see on the left side, all different types of indoor units are available in this software which we are going to use, and branches are also available. Whether we want to use a Y-shaped branching joint, we want to use 4 branching header, we want to use 8 branching header. So there are different types of indoor units are available here, and outdoor model, as you can select from here also, or when you will double click this outdoor unit, then you can select your outdoor unit. As you can see, this is our outdoor unit in the refrigerant piping diagram, and this is our indoor units, but these are dummy units. We will have to select the indoor units from here and then drag into the dummy units. But before starting this refrigerant piping diagram, let's move back to our Excel sheet. So as you can see that based on our Excel sheet load calculation, heating and cooling, we'll select our indoor units. So first I'm gonna draw the piping diagram first. As you can see that we have a total 11 indoor units here in our system. So I have to use 11 indoor units over here. So let me create this piping diagram first. So I'm gonna use this Y-shaped branching joint and 4 branching header combination in my refrigerant piping diagram. So I have to use 11 indoor units first. So let me create this Y branching here also. When you click this dummy unit and right click on this one, there's option insert. You can insert Y-shaped branching joint, 4 branching header, or 8 branching header. So I'm gonna use Y branching header here, 1. So now I have 3 indoor unit, depending on what type of configuration you are going to use. So according to your you can select a Y-shaped branching header, or you can select 4 branching header or 8 branching header. So I'm gonna use one more Y branching joint here, and one more here, and then again I'm gonna use Y branching joint here, and one more Y branching here, one more Y branching here, and then I will use 4 branching header here. So how many indoor units I have now? 1 2 3 4 5 6 7 8 9 10 11. So now I have created my refrigerant piping diagram, and I have 11 indoor units available here in my refrigerant piping diagram system, VRF system. So now I am going to use the indoor units based on my load calculation, cooling and heating load. So first move back to our software. Let's suppose I'm gonna use this for this office, which has 6 kilowatt cooling load and 6.2 kilowatt heating load. Office 1. I'm gonna use this 4-way air discharge cassette type unit. You just need to select and drag over here and then leave it. So your indoor machine will automatically come over here. As you can see that there are different models available here. You can select from them also, like slim duct type, concealed duct, high static pressure type, or 1-way air discharge, high wall 2 series, 4 series. So whatever you want, you can select the indoor unit from here. So I'm gonna use this 4-way air discharge cassette type unit, and the indoor unit name which I'm going to use here is VRF1, and space name, as you can see, the office 1. So I'm gonna name it office 1, and floor, we have a ground floor there, so it's GF. And there you have one option, that is indoor unit selection method. If you will select this auto, then it will gonna select your capacity rank of the machine, which is basically the horsepower of the machine based on our calculated load. If you will uncheck this one, you can select the machine from all the models available over here. So I'm gonna use this auto method over here, and the indoor design condition which I'm gonna use over here, indoor cooling dry bulb, I'm gonna use is 75. That's okay, that is 23.8 degrees Celsius. And indoor wet bulb temperature, that is automatically calculated when I will give the humidity value. The humidity value which I'm going to use here is 50% for design. For indoor design comfort, it is recommended to have 50% relative humidity. As you see that if I change this to 40, our cooling wet bulb temperature will be changed. So I'm gonna use this 50 as per design recommendation. So I'm gonna use 50. So wet bulb over here is 62.6 degrees Fahrenheit, and the indoor heating dry bulb temperature I'm gonna use over here is 70 degrees Fahrenheit. And now I have to mention my cooling and heating load. So cooling load I'm gonna mention over here now, that is 6 kilowatt. So I'm gonna use 6 kilowatt here, and sensible, let's say our sensible is 4.6, and what is our heating load over here, that is 6.2 kilowatt for office 1. So I'm going to use 6.2 kilowatt here. So as you can see that based on our these loads 6 and 6.2, this machine is automatically selected based on our heating and cooling loads. So now I have to give the piping length from the joint equivalent. So from this joint to the machine I have to mention the pipe length. So let's suppose we have this length is, we have to mention equivalent and actual length. Let's say our equivalent length is 2.8 meters and actual length is 2.5 meters. and we have to mention the height difference between indoor and outdoor units also. Let's say our outdoor unit is installed at the roof, and the height difference between our roof and the ground floor ceiling is 4.5 meter. Whatever the height is, you have to mention here. Let's say it's 4.5, so I will mention 4.5 meter here. So this fan speed, I'm gonna select is high. Okay, I don't want to use any heater here. Or okay, so all input are done. So once you select the machine and all inputs are done, so you just need to save it. If any input is missing, it will give you some error, so you need to specify that input. So I'm gonna close this one, and now I'm gonna select the second machine over here. So this time I'm gonna use, what is the space here, meeting room. So meeting room, now I'm gonna use this duct, concealed duct standard type unit. I'm going to use over here, indoor unit. So just drag and drop here. Once it's done, in the same way you have to fill this or give all the inputs. This is our meeting room, and room name is this is VRF 2, and room name is meeting room, and floor is ground floor. I'm gonna select auto again. These conditions are same, only this I'm going to change. So this one, you remember that I have used the same condition for the first indoor unit, same I'm going to use for the second indoor unit. And the loads for the meeting room are 4.6 kilowatt for cooling and 5 for heating. 4.6 and 5. So 4.6 for cooling and 5 for heating. Let's say its sensible load is 3.9 and heating is 5. So now I have to specify the piping length from the joint equivalent. So from this joint to the machine, I have to specify the length. Let's say I'm gonna use equivalent is 2.8 and actual 2.5 meter, and height difference between indoor and outdoor units same, 4.5 meter, and then save it and then close it. So now I'm going to use I'm going to specify the third indoor unit for third space, that is office 2. So this time I'm gonna use the same 4-way cassette type unit. So instead of again drag and drop here, I'm gonna copy the same data. If you will just right click on this machine and copy, and then here right click again and then paste. So same data will be pasted here, so I'm just gonna modify it. Just double click this machine. I'm gonna select here VRF 3, office space 2, ground floor, auto selection, and this 70. Okay, and what is our load here? As you can see, for office, cooling 3.8, heating 3.3, 3.8, 3.3. So 3.8 kilowatt cooling. Let's say this is 3, and heating how much? 3.3. 3.3. So we have specified our heating and cooling loads, and now we have to specify the length again. Let's say it's same, 2.8 from here to here, it's 2.8 equivalent we are going to use, and 2.5 is the actual we are going to use, and height will same, that is 4.5 meter. So save this one and then close it. So now I have to specify the fourth indoor unit for number 4 space, that is locker room. So this time I'm gonna use this high wall type unit over here, 3 series or 7 series. So I just have to drag and drop here into the dummy indoor unit, and then I'm gonna use its name as VRF 4. Room name is locker room, and floor is ground floor, and I'm gonna use the auto selection method over here. Same everything except this last one I'm gonna change to 70 heating dryable temperature. And now I have to specify the load. Locker room 1, it's cooling 3 and heating 3.1. 3 and 3.1. 3, let's say the sensible is 2.4 and 3.1 is the heating load. So 3 and 3.1 we have specified here, and now we have to specify this length again. So let's say I'm gonna use same 2.5, 2.8 equivalent and 2.5 actual length. And height difference again I'm gonna use same between indoor outdoor unit is 4.5 meter, because this one is on the ground floor and our outdoor unit was on the first floor, and this is locker room 1. Here locker room 1. Then after specifying all the inputs, then save it and close it. So now I'm gonna select one more indoor unit for our next space, that is meeting room 2. So let's say I'm gonna select the same unit which I have used here, standard duct type, for meeting room 2. This is for meeting room 1. We should mention this one as meeting room 1. Save this one. So instead of drag and drop another, I want to copy the same data, just edit this one. So right click this one, copy this machine data, and right click, paste. So now I'm gonna edit the data for this meeting room 2. So this VRF is 5. This is our VRF 5, and meeting room 2, same ground floor, auto method. This is all okay. And now we have to specify our loads. Let's say our cooling load is 11.8 kilowatt and heating is 12. 11.8 kilowatt is cooling, and let's say our sensible is 10.2, and our heating load, that is 12 kilowatt. So I'm gonna use the same length from the joint to the machine, that is 2.8 meter equivalent and actual 2.5, and this is 4.5 height between indoor and outdoor unit. So just save it, then close this tab. So now I will input the data for another space, that is locker room 2. So first locker room I have used this 3 series high side wall. So I'm gonna copy the data from here and then paste here on this dummy indoor unit, and then I will double click to modify the data. This is our VRF 6 and locker room 2, ground floor, auto selection method, and now I have to add the cooling and heating load. So cooling load is 3 and heating load is 3, both are 3 kilowatt. So 3, let's say this is 2.4 and this is also 3. So cooling is 3 kilowatt, heating is 2 kilowatt, and same piping length I'm gonna use from this joint to this machine, equivalent and same actual. And height between indoor and outdoor unit, it's same 4.5. I'm gonna use save and then close this one. So one more indoor unit for next space, that is our restroom. So for restroom I'm gonna use this 4-way cassette type. I will copy the data and then I will paste here. Then double click this one to edit the data, and this would be our VRF 7 and its room is restroom. So on the ground floor, auto selection method we are going to use, and its cooling load is 4.6, heating is 4.8. 4.6, 4.8, and let's say our sensible is 3.6 here, it's 5. So this is our cooling 4.6 and heating is 4.8. Okay, so the length, pipe length from the joint, from this joint to this machine is 2.8 equivalent and 2.5 actual. So we can save this one. And then close it. So there are 4 more indoor units which we have to add over here. So what is our next space? That is smoking room. So I'm gonna use cassette type here again. Copy data and paste on this dummy unit. Then double click to edit the data. This is our VRF 8, that's okay, and this is our smoking room, same ground floor, auto selection method, and we have to specify the loads, 3 for heating and 3 for cooling and 3.1 for heating, 3 and 3.1. So 3, 3.1, and let's say sensible is 2.4. So we have specified, and length, so the length which I'm gonna use now from this header, 4 branching header till this machine is 2.8 equivalent and 2.5 actual, and height is same because this is on the ground floor and our outdoor is on the roof, so it's 4.5 meter. So I'm gonna save it and then close it. Again I'm gonna, so next space is reception room. So I'm gonna copy this data, paste on this dummy unit, double click this indoor unit and edit your data. This VRF 9 and this is our reception room. So I'm gonna change this name to reception room. Reception room, it's on the ground floor, and these conditions are same. Now I have to specify the loads. Let's say our cooling we have calculated is 3.8, heating is 3.9, 3.8 and 3.9. So this is 3.8 and this is 3.9 and let's say our sensible is 3. So now I have to specify the length from the joint. So let's say the length from this joint to this machine is 5.8 equivalent and 5.5 actual. So I'm going to use 5.8 equivalent and 5.5 actual. So this height is same, and save the data. Then close it. Then move to the next space, that is office 3 space. With the cooling load is 4.8 and heating load is 4.5. So I'm gonna copy this data from office 2 over here, paste, and double click the indoor unit. This will be our VRF 10, and this is our office 3 ground floor, and then we have to specify the cooling and heating loads. Cooling is 4.8, heating is 4.5, and heating is 4.5. Let's say our sensible is 3, sensible cooling load is 3.8. So now I have to specify the piping length from the joint. So let's say from this joint to this machine, the equivalent piping length is 8.8 meters and actual is 8.5 meters. And then save it, and close this one. So now the last page is here, that is reception area. So I'm gonna use standard duct type here for reception area. So I'm gonna copy this data and paste over here. Then I'm gonna double click this indoor unit and modify the data. This is VRF 11 and this is for reception area. It's on the ground floor, auto selection method. So capacity for cooling is 3 and heating is 3.1. So it is 3 for cooling, 3.1 for heating. So sensible cooling I'm gonna use, let's say it's 2.45, and again I have to specify the piping length from the joint, equivalent and the actual. So let's say the length of this piping from our A4 branching header to this machine is 11.8 equivalent, and the actual I'm going to use here is 11.5, and this is 4.5 meter. Then save this machine data and then close it. So now all the indoor units data has been specified. Now we're gonna move to our outdoor units. As you can see that since we have specified all the capacities for our indoor units, so based on our indoor units capacities, outdoor unit is automatically selected over here. Now the unit which is selected here is MMY AP2416 HT8P, that is 24 horsepower system is selected based on our load calculation for all indoor units. So if you wanna modify the data or edit the data, you just double click outdoor unit. So the unit type which I'm gonna select over here is SMMSE. There are different series available here in Toshiba. So I'm gonna select this SMMSE Since I have checked this auto, that's why this machine is selected based on my indoor unit capacities or load calculation. So and the maximum selection percentage which I have selected here is 100% based on my indoor and outdoor unit capacity ratios. So there are few more things I have to specify here, that is the main piping length. As you can see that this is 0 right now, so I have to specify this main piping length. If you remember my first video, I have told you about the main piping of the refrigerant VRF system. The main piping length is from this T connection to the first branching section. This is our main piping length over here, as you can see. So I have to specify this main piping length actual and equivalent. So let's say my main piping length actual is 6 meter and equivalent is 6.5 meter. So I have used this length over here. Now I have to specify the T-shape outdoor unit distance LA and LB. As you see, this is our outdoor units here. This is first one and this is the second one. So LA is the distance from outdoor unit till this pipe, and LB is the distance from here to this main pipe. So this is LA and this is LB. We have to specify these lengths. So let's say the LA actual which I have used here is let's say it is 2.7 for LA, and LB is also 2.7, and equivalent, let's say it is 3 for LA and 3 for LB. And one more thing we have to specify here is the height difference between these two outdoor units. Since I want both of them on the same floor, same level, so I'm gonna use 0 meter here. If you have height difference between them, then you can specify that difference in a meter over here also. So since I'm gonna use both of them on the same floor, so I have specified 0. There's no height difference between these two outdoor units. So after editing this data, you just save it and then exit this one. So as you can see that we have specified this main piping length, but there are few more entries which we have to add over here. So as you know that we have added this pipe length, refrigerant piping length, from this Y branching joint to the machine, but we did not add the length from branching joint to the branching joint. As you can see, it is 0 here, 0, it is 0, it is 0. So we have specified this length, but we did not specify this length. So now I'm gonna specify the length between the joints, Y-shaped branching joints. So I'm gonna select this branching joint to specify the length between this joint and this joint. So just double click this Y branching joint, and its name is Y2. So now I'm gonna mention the actual length and equivalent length. Let's say our actual length is 2.7 meter here and equivalent length is 3 meter. So okay, so as you can see that the lengths are mentioned here, 2.7 and 3. So now I'm gonna specifying this length between two joints. So I'm gonna select this joint, and let's say the length which I'm used here is 3.2 meter actual and 3.5 meter equivalent. So it will come here. Now I have to specify between this joint and this joint. So let's say same, I'm gonna use 3.2 and equivalent is 3.5. So whatever your lengths are here, you have to specify here in your project. And if you don't select these lengths, then you will get an error. Why will you will check your system information. So let's say I will go over there. As you can see that this is an error, so we need to fix that one. Total pipe actual length is not mentioned. It's 0 meter pipe length exist. So when I specify all the lengths over there, so this error will be gone. So we need to specify all the lengths over here. So now I have to specify the length between this joint and this joint. Right now it's 0. So I'll select this one. Let's say the actual length is 6.2 and equivalent is 6.5 for this Wi-Fi joint. So this length will appear here, and now I will specify this length from this joint to this joint. Just double click this joint Y6 and mention the length. Let's say actual is 2.7 and equivalent is 3. Okay, now between these two joints, same, I'll suppose this 2.7 and this one is 3. So now I have to specify the length between this Y branching joint and this 4 branching header. So I have to specify the length. So let's say it's 2.7 actual length and equivalent is 3. So it will appear here. Okay, so all other lengths I have already specified there. So this is how you have to specify all the refrigerant piping length. So as you can see that we have put all the information in our project, and we have designed our VRF system based on our load calculations. And you can see this dia is automatically calculated both for liquid and the gas piping based on our load calculations. As you can see that by specifying the length between the joints, that is Y-shaped branching joint and all the joints, we have specified the length. Before that, the outdoor unit capacity was 24, but now it is 26 horsepower. As you can see over here, one outdoor unit 14 and the other one is 12, so total 26 horsepower. So all these factors matter a lot while selecting your indoor and outdoor units. We specified the length over here between the joints. So this is 26 horsepower system of the outdoor unit, that is divided into 14 horsepower and 12 horsepower, and this one is header and this one is follower. If you remember, I told you about the header and the follower. Header is that unit that is nearest to the first branching section, that's why this is called header, and the other is called follower. And they should be arranged in the capacity according to their capacity. 14 horsepower should come first and 12 horsepower should come second, sorry. So this one comes first, this is second, this is header, this is follower. And if you want to study these piping diameters and lengths, you can see the piping legend over here. The first one is for the gas pipe diameter, second liquid pipe diameter, third is actual length, fourth is equivalent length. So this first one is gas pipe, that is 7 by 8 inches, second is liquid pipe diameter, that is half inches, and 2.7 meters the actual length and 3 meters the equivalent length. So this is how you can study the legend for piping. In the same way, legends are mentioned here for outdoor units and indoor units. So this is how you can design your VRF system based on your load calculation. You have to specify your load calculation for indoor units, and using auto selection method you can select your outdoor units based on your indoor load calculations and selection. So in the last but before that I will click the system information. So if I click the system information, you can see that this is the specification column, and this one is a design column, and this is the result column. So make sure that all of them should be tick in the end. If it is not tick, then you need to correct that error. So as you can see, this is the design column, and in our project this is basically the limit from the supplier, this SPEC specs or specification from the supplier. This is the limit from the supplier, so we need to our design should be less than this specified limit, because this is the limit. So for example, total piping length actual allowed by supplier is 300 meters. In our case it's 80.3, so 80.3 is less than 300, that's why it's ticked. Same over here, maximum equivalent length of the outdoor unit connecting pipe is 10 is allowed maximum, and we have 3 over here, so we are good. So as additional refrigerant charge amount that's automatically calculated for our whole system is 14.76 additional refrigerant amount is required to charge. And outdoor unit capacity is 26, as you see over here there is 26 horsepower, and 2 outdoor units we have used, one 14 and the other 12, and indoor units are 11 we have used. Indoor unit capacity is 24.45 is the total capacity of the indoor units, and indoor unit to the outdoor unit capacity ratio, that is outdoor unit diversity, is 94%, because indoor unit is 24.5 and outdoor unit is 26, so 24.5 divided by 26, outdoor unit diversity will be 94%. So 94, this is the design, this is the allowed limit, that is 50, it should be between 50 to 135%, and our is 94%, so that's why it's good. And for this pipe equivalent length actual that is allowed from the supplier is 180 meters, and in our case, our project, that is 34.5 meters, so we are in the safe range. So this is how you have to compare your design with the limitations from the supplier. So in the end we will generate an output from our project. So you just need to click this output over here, or you can go to edit and you can generate an output data. Also you will get the electrical results also here. When we generate the report, we will get the detailed design of this electrical. So let's go to the output tab and select this one. So whatever the things you need, you can select and you can generate the output. You can generate report, table, piping, wiring and price list, everything. So whatever you need, you just select this one. If you need Excel, you can, for all this you can select Excel. If you need CAD, you can select the CAD. If you need PDF, you can select PDF. So right now I'm gonna select only PDF. So now I'm gonna save these reports, tables and piping and wiring diagrams, and we'll discuss the results. Let's say I'm gonna save here. Okay, just wait a moment, it will take maybe 1 minute. Once everything is saved there, I will discuss the results related to the VRF system design. We will discuss the report, table, piping and wiring diagrams, and the price list also. Just wait a little. So in my next video I will discuss with you guys about the additional refrigerant charge calculation, and we'll also use the other method for refrigerant piping design, over here for the VRF system, that is wizard type selection, later in another video. Just wait a moment. Okay, it's done. So move here. Okay, these are all the PDF files which we have selected over there. So I'm gonna open this first one, the piping diagram, refrigerant piping diagram for the VRF system, which we have designed there. So as you can see that this is the refrigerant piping diagram which we have created over there. So you can take a print of this refrigerant piping diagram because everything is mentioned here, all inputs are there, load is mentioned there, and machine size is also mentioned there, pipe sizes are mentioned, liquid gas pipe size mentioned, their lengths are mentioned, what are the accessories used here, Y-shaped branching joints, and their types are also mentioned. For example, this is RBMBY105E and this is RBMBY205E. So let's go to piping and wiring diagram in the combined state. So as you can see that this is our outdoor unit which we have selected for our system, that is 26 horsepower system. As you can see, this is blue one is the refrigerant piping over here, and this red one is the electrical cabling here for from outdoor unit to the indoor units. So as you can see that we have all the indoor units over here, total 11 indoor units, and you can see that their gas and liquid pipe sizing are mentioned there, and the lengths are also mentioned there, from this joint to this machine, then this joint to this machine, all lengths are mentioned there, and these lengths are also mentioned from joint to joint lengths, and refrigerant piping dias are also mentioned for liquid and gas pipe. And as you can see that electrical wiring for the cables, their sizing is also available here. So if you go over there, you can see the outdoor unit name and its capacity, that is horsepower, and indoor unit total capacity, outdoor unit capacity, everything is mentioned here, and how much is the additional refrigerant charge calculation is required for our project is 14.76. So this much additional refrigerant is required for our project. And if you go over there, you can find the indoor and outdoor units and the accessories, Y-shaped joints, header, whatever we use in our project is mentioned here, and their quantities are also mentioned here. And this is the wiring size and length for the electrical data. Over here you can see what kind of wire we can use, it's mentioned here for the outdoor unit, for the indoor units, and for remote controls, everything is mentioned here, their wiring, labeling, polarity, their size, length, everything is mentioned here in our report. And you can see the price list also here, our project name, everything is mentioned here. Then outdoor unit, only one we have used, and indoor units, there are different types of indoor units and their quantities available, whatever the price you can mention here. And outdoor unit connection kit which we have used is this model, only one quantity. Then Y-shaped branching joints, we have used these types, this quantity, and then header, and then accessories. So this is the pricing list which you can use, and it's easy for you to order the equipments and accessories for your VRF system. So also you have a equipment list, and you have a report drawing. So this is the same thing which we already discussed before. The electrical wiring is there, and refrigerant piping is there, and you have equipment catalog for indoor units and outdoor units. So this is how you can generate your report after finish your design of the VRF system. So it will be easy for you to interpret the results later after your design. If you have these reports, you can easily proceed for installation of the machines and everything. In this video I will tell you guys how to use psychrometric chart to get the relative humidity, dry bulb, wet bulb temperature values, because when we are calculating the heat load, this is very important parameters that need to be input. So here you can see that I have a train psychrometric chart software open over here. So before starting, I want to show you the basics about this chart. So let me zoom in. As you can see that this is the x-axis, where there we have a dry bulb temperature in degrees Fahrenheit, and then y-axis we have a humidity ratio in grains per lb, and these curved lines is 10%, 20%, 30%, 40%. These are the relative humidity lines, and last one is the wet bulb temperature line. As you can see that this line, this is a wet bulb temperature lines. So if you remember that in my tutorial number 16 and 17, where I was calculating the heat load, so there I have the E20 sheet, same E20 sheet. So as you can see over here, we need to input the design conditions, outside design and indoor design. Let's say this is the building located in Dubai, and outdoor design condition of Dubai dry bulb temperature is 107 degrees Fahrenheit and wet bulb is 75 degrees Fahrenheit. These values you can get from local authorities in your location. This is provided by Dubai municipality, so you can get in your location from the local authorities. So as we know that outdoor design temperature for Dubai is dry bulb 107 degrees Fahrenheit and wet bulb is 75 degrees Fahrenheit. So we need to get the relative humidity and humidity ratio from psychrometric chart. So let's move back to our psychrometric chart. Let me zoom out this one. Okay, if we go to chart and go to set points and then add points, as we know that outside design dry bulb temperature for Dubai is 107 degrees Fahrenheit and wet bulb is 75 degrees Fahrenheit. As you can see that the other parameters are also calculated over here. So we our concern is about humidity ratio and relative humidity. So if we have a dry bulb 107, wet bulb is 75, then our relative humidity is 22.4%, and humidity ratio, this W is representing the humidity ratio. So humidity ratio is 79.5 grains per lb. So as you can see in our Excel sheet E20 form, we have input our relative humidity as per psychrometric chart is 22.4% and humidity ratio is 79.5 grains per lb. So now for indoor design conditions, for the most comfort system, we know that for human comfort system, indoor design temperature is from 75 to 78.5 degrees Fahrenheit. So we have selected 75 degrees Fahrenheit indoor design temperature. And for most comfortable system, indoor design relative humidity is about 50 to 60%. That's why we have selected 50% relative humidity. So we know that indoor design dry bulb temperature is 75 and relative humidity is 50%. So now we get the wet bulb temperature and humidity ratio from psychrometric chart. So let's move back to our psychrometric chart. So we know that indoor design dry bulb temperature is 75 degrees Fahrenheit, and we know the relative humidity, indoor design relative humidity is 50%. So as you can see that we have these two parameters. So the wet bulb is 62.5 degrees Fahrenheit and humidity ratio calculated over here is 64.9 grains per lb. So as you can see that we have used the same values over here, humidity ratio and wet bulb temperature. 62.5 is the wet bulb, and 64.9 is the humidity ratio. So this is how you can get the parameters from the psychrometric chart while designing your HVAC system. So this software is really easy to use. You can get the accurate values. So I hope you guys learned something from this.